Morning, dear students. So, last session we have talked about continuous beams with the overhanging portion, how to solve that by Kani's method. In this session, let's see how you take up the continuous beam with the sinking of supports, how you solve by Kani's method. So, you know how the moments develop when a particular support sinks. So let's once again see it. What is the effect of sinking on the uh, end moments, fixed end moments developed in the beam? So let's take beam AB, which is having some span L. Okay, so let us say B has got settled down by an amount of delta. Okay, so how the beam is going to bend, the possible way of bending is this one, is how it bends. So now you see the moment shall develop anti-clockwise at A and also anti-clockwise at B to arrive at these this deformed shape. Okay, reason that the anti-clockwise moment will make or will satisfy theta A 0 and theta B 0. So to develop such condition, you have to have the anti-clockwise moments. The value being 6 EI delta by L square. That is the moment value developed. So right hand support, if right hand support sinks, then we will have anti-clockwise moments, which means they are negative. We are writing anti-clockwise moments as negative moments. So both the values are minus. Similarly, for the same span AB, the support A sink by an amount of delta. Now you can see this is how the beam shall bend, where the moment developed at A shall be clockwise. Similarly, at B, it shall be clockwise. The clockwise moment here, clockwise moment here, clockwise moment at A, clockwise moment at B makes the beam to deform in this manner, which is the suitable deformed shape. So now you see the same value 6 ci delta by L square, but the clockwise moments are developed. So left hand support sinks, then the moments developed are clockwise, fixed end moments. Hence they are taken as positive. Okay, right? So with these notations and the values, and you have to modify the fixed end moments you wrote for the load cases, then the rest of the procedure will be same. Okay, so how do you solve? So there will be only change in step 1. So step 1, you are writing fixed end moments. So fixed end moments are written. So what you are going to do now is you have to write the fixed end moment values for corresponding loads given. I mean, you will have both sinking effect as well as loads. So I'll just make it uh, in terms of notation instead of writing it. So fixed end moment, I'll just do it like this. Fixed end moment due to load plus, I mean plus in the sense plus or minus according to their sign. So fixed end moment due to sinking. That will give you final fixed end moments which are modified. So those we will take up and we will proceed for the rest of the procedure in the similar manner as discussed in the earlier cases. So now take this problem of a continuous beam having A, B, C, D nodes simply supported over each support consists of span AB, BC, CD of AB 3 meters, BC 4 meters, CD 3 meters respectively. The beam carries a UDL 12 kilonewton per meter over the entire span. Now support B and C sinking by 2 mm and 7 mm. Right. So support B is sinking by 2 mm, support C is sinking by 7 mm. Then solve this problem by kani's method to determine the moments over each support. Use kani's method. As the sinking is involved, you need Young's modulus and moment of inertia values. So take these values. Young's modulus 200 gigapascal, moment of inertia 4010 power 4 mm power 4, and draw BMD and SFD. Okay, so just for your verification, cross verification, to check the solution, I'm giving you the solution here. Okay, so finally you will be getting this solution. So final end moment at A is 0 because A is also simple support, and D is also simple support, whereas B and C are continuous. So total moment at B 0, total moment at C 0, whereas D is end hinge 0 moment. So settlement at B is less, settlement at C is more. Hence, the total moment developed at B is more than C. So release is more at C and release is less at B. Whereas A complete release, so D is also having complete release of moments. Okay, right. So hence the final end moments for this problem, you have to get this solution. So try this one and check the solution with this. So there is no change in the procedure. Whatever we have discussed for this case of continuous beam with simple end shall be followed, and you have to incorporate the fixed end moments from sinking with this formula 6EI delta by L square, and then find fixed end moments which are to be modified by combining fixed end moments from loads and fixed end moments from sinking. Then step 2 similar, step 3, step 4 all are very similar. Okay, so your solution shall match with this. Uh, Maybe the 0.01 error is permitted, as I said. So we will look for first decimal to be same in calculating rotation contributions. Okay, right. Thank you. We'll come back to the next session to discuss with the frames, case portal frames.